Welcome everyone to our plane measuration series, the SSE aspect of it. Today we'll be dealing with length of a chord. We have a given diagram as shown on the screen. Length of chord AB is equals to 2r sine theta over 2. On the other hand, if theta is not given, but a shape like the one below is given, we apply Pythagoras theorem to solve for the length of chord. Next, we take some examples. 2006/29 NECO December. A chord of length 30 cm is 8 cm away from the center of the cycle. What is the radius of the cycle? The options are given. Solution. The sketch of the given problem is as shown below. AB is equals to 30 cm. That is AC plus AB. Hence, we break it down to show the values in the right angle triangle there. By Pythagoras rule, in triangle OAC, OA square is equals to AC square plus OC square. From that right angle triangle, we have that OA square will be equals to 15 square plus 8 square. And the value is, at the right hand side, we have 225 plus 64. Thus, OA square will be equals to 289. To get OA, we take the square root of 289. And that will give us 70 cm. Another example. The distance of a chord of a cycle of radius 20 cm from the center of the cycle is 16 cm. Calculate the length of the chord. The options are given. Solution. The required sketch based on the data given is as shown below. From the diagram, our required length is AB, but AB is equals to AC plus BC, and AC is equals to BC. In the right angle triangle OAC, by Pythagoras rule, 20 square is equals to 16 square plus AC square. Making AC square the subject of formula, we have AC square will be equals to 20 square minus 16 square. And the result is, at the right hand side, will be 400 minus 256. Thus, AC square will be equals to 144. From here, we have that AC is equals to square root of 144, which is equals to 12 cm. Thus, AB, which is equals to AC plus BC, implies 12 plus 12, which is 24 cm. Another example. O is the center of the above cycle, and ASB is the chord. Find OX. The options are given. Solution. By Pythagoras rule, OA square is equals to AS square plus OS square. And we note that AS is equals to BS. Reason, the line joining the center of the cycle to the midpoint of a chord is perpendicular to the chord. Thus, we can substitute for our values. That will be 10 square equals to 8 square plus OS square. The result is 10 square minus 8 square will be equals to OS square. Making OS square the subject formula, we have 10 square minus 8 square will be equals to OS square. Applying difference of 2 square to the left hand side of the equation, we have 10 minus 8, bracket open and close. Then another bracket open, 10 plus 8, bracket open and close, will be equals to OS square. And the result will be, at the left hand side, will be 2 times 18 will be equals to OS square. And that's 36 equals to OS square. From here, OS will be equals to square root of 36, which is equals to 6 cm. Another example. The length of a chord is 24 cm. If the distance of the chord is 8 cm from the center of the cycle, find the radius of the cycle correct to 2 decimal places. The options are given. Solution. The sketch of the given data is as shown in the screen. AB is equals to 24 cm. That is AC plus CB. Now, by Pythagoras rule, in the right angle triangle OAC, OA square will be equals to AC square plus OC square. And the result is, substituting for the given values, we have OA square will be equals to 12 square plus 8 square. And the right hand side will give us 144 plus 64. Thus, OA square will be equals to 208. And we have that our OA will be equals to square root of 208, which is equals to 14.422 cm. Approximately 14.42 cm to 2 decimal places. Another example. An arc PQ of a cycle of radius 40 cm subtends an angle of 74 degrees at the center of the cycle. Calculate correct to 2 decimal places. A, length of the chord PQ. B, distance of the chord PQ from the center of the cycle. C, area of triangle POQ. Solution. The sketch of the cycle with center O is as shown on the screen. Our first problem, which is length of the chord with a given angle at the center of the cycle as shown, it will be equals to 2r sine theta over 2. Substituting for the given value, it will be equals to 2 times 14 times sine 74 over 2. The result is 28 times sine 37, and that will give us 28 times 0.6018, which is equals to 16.8504 cm, approximately equals to 16.85 cm to 2 decimal places. The other part of the solution is left for our learners to go through in the textbook. Next, we'll take another example. A chord xy of a cycle with center O and radius 5.32 cm has angle SOY equals to 140 degrees. What is the length of the chord to the nearest centimeter? The options are given. Solution. Length of a chord is equals to 2r sine theta over 2. From the given data, the result will be, substituting for our given values, we have 2 times 5.32 times sine 140 over 2. And that's equals to 10.64 times sine 70. The result is 9.998 cm, which is approximately also 10 centimeter to the nearest cm. We've come to the end of the examples under this subheading. Next, we have some exercises at page 355 of the Hidden Fact in USSC Mathematics. Please try your hands on the exercises. The answers are given at the answer section of the book. Hard copies are available in bookshop. If you are interested in our soft copy, please, the website is displayed at the bottom of the screen. You can visit it. Thank you.